we have seen rationals. The other half of this unit is radicals. Radicals is another name for basically root. So like square root, cube root, fourth root. Fancy term for that in math is a radical. Let me describe some of the parts of a radical. This little number right here out front, in front of our radical symbol, is called the root. You can also see it called the index. It's called a root because usually we just call out the number and then end with root. So square root. This is a 3, cube root. 4, fourth root, etc. And then anything inside of our radical is called a radicand. So outside the root, inside the radicand. So nomenclature, if you don't see a number out in front, it's assumed to be a 2. Everybody should know this, right? Don't see a number, you call this a square root still. Even though you don't see the 2, it's a square root. The only time in math to where if you don't see something, they don't write something, it's not a 1. In this case, for square roots, it's a 2. Mostly because mathematicians, like I said, they're lazy. They just got tired of writing a 2. What we want to do with radicals is add, subtract, multiply, and divide. But before we do that, we have to know how to simplify. You'll need to simplify a radical first before you can add or subtract. And then when multiply and divide, you'll have to simplify a radical afterwards. So let me show you the steps to go through in simplifying a radical. And you'll note that it's the exact same as if you're going to find the GCF. So if I have two numbers like 2 times 3, if I break it down into the prime multiples and I have 3 times 5, what would be the GCF here? What am I circling?
3s.
Yeah, what they have in common, so the GCF would be a 3. Well, we're kind of going to do the same thing here. So I want to take 18 and break it down into its prime multiples. Primes 2, 3, 5, 7, 11. We'll start with 2. Does 2 go into 18?
Mm-hmm.
How many times?
9.
9 times. Does 2 go into 9?
No.
All right, we'll move on to the next. Does 3 go into 9?
Yes.
3 goes into 9 3 times, and 3 is prime. So 18 breaks down into 2 times 3 times 3. That's the first step. Second, note, I don't see my number, but it's assumed to be a,
1.
no, 2. Remember, this is the only time where the number is not there, that it's going to be a 2. So we're talking about square roots. This number tells you what you're looking for as far as things in common. I'm looking for pairs, right? I'm looking for sets of 2s. If this was a 4, I'm looking for 4 of the kind. If this was a 7, I'm looking for 7 of a kind. In this case, I'm looking for 2 of a kind, which I see is right here, right? So I'm going to circle these 2 3s. And now let me rewrite my radical. What did I not circle?
The 2.
I didn't circle a 2. Oops, doing that again. I didn't circle a 2, so I'm going to keep 2 inside. And what I did circle was a pair of 3s, so I'm just going to take out a 3. Likewise with the GCF, I circled 2 3s, but I didn't say the GCF was 9 or 6. It's just a 3. In this case, a 3 is what I had a set of 2 ofs. So I'm going to take out a 3, and then I'm done.
That's the answer?
Yeah, 3 times square root of 2. So we found that square root of 18 simplifies to 3 times square root of 2. We can actually check this with our calculator.
Just put that in there?
Yeah, so do the square root of 18, and you'll get a number. Now take 3 square root of 2, and you should get the same number, right? Because it's the same thing, just simplified. We did, so it looks like I don't have any issues here. I'll accept 3 times square root of 2. Let's look at that again. So again, I'm dealing with square root. Let's simplify square root of 96. So let's find our prime multiples. Does 2 go into 96?
Yeah. Yes.
How many times?
7.
48.
Oh, 48. How'd you get that?
Number 6. If you don't have that, use a calculator. Just use a calculator. Divide by 2. Does 2 go into 48?
Yes.
How many times?
24.
24. Does 2 go into 24?
Yes.
12 times. Does 2 go into 12?
Yes.
6 times. Does 2 go into 6?
Yes. Well, look,
3 times, and 3 is prime. Now again, when you get big numbers like this, please check 2 times 2 times 2 times 2 times 2 times 3 in your calculator and make sure you get 96 and you didn't put too many 2's or miss one. So I've written my prime multiples and I'm looking at square root, so I'm looking for sets of 2. Where do you see that?
Right there, so 1 set, 2 set, and then you got the 2 and the 3 that's left.
Very good. So I have pair of 2's,
Mhm.
another pair of 2's, and then nothing else. So what did I not circle?
The 2 and the 3.
2 times 3 is,
6.
again, we're prime multiples, we're multiplying, don't put 5, we're not adding. 2 times 3 is 6.
You put that 2 at the top.
Yeah, I could. Usually you don't have to write 2 at the top, but I'll do it there. And then what am I taking out? A 2 and another 2, which gives me
4.
4. So the answer is 4
Oh yeah.
times the square root
You don't have to put the
of 6.
little exponent at the top.
Not with 2, no.
Oh.
Not with the square root. So once again, we can go to our calculator. Square root of 96 for square root of 6.
Why does your decimal go like that?
Because it's an irrational number, so it can't be divisible by, But it can't be turned into a fraction?
Whole number.
what's that?
It's never gonna be a whole number.
Oh, well, what's the square root of 16?
Like 4.
4.
Oh,
So square root gives you an answer of this number multiplied twice by itself, gives you the number inside the radicand.
okay.
So 4 times 4 is the radicand of 16. 9.797958971, and it probably continues to infinity, gives me a radicand of 96. So it gives you what number you have to square by itself. Okay, so 4 squared root of 6. Now, if you see a number on the outside, just ignore it for now. So I'm going to move this 10 out here, and I know it's being multiplied to my radical. So don't get thrown off when you see that number there. Just put it aside, look at your radical, and simplify it. Well, we've already simplified this, right? To 4 square root of 6. And once you simplified it, now bring that number back and multiply it. So I have this number 10 on the outside. I 4 came out of here, so now let me multiply these together. 10 times 4 is 40 with the square root of 6. So that's all you have to do. Just put this number on hold, simplify your radical, then multiply anything that comes out to that number. Now let's look at variables and what happens when they go inside a radical. Same process, same thing with GCF. We'll just write it out. So let me look at my prime multiples. 2 goes into 45.
0.
No, it doesn't work. 3 goes into 45 how many times? 15. Does 3 go into 15?
Yeah.
How many times?
5.
5, and 5 is prime. So 45 is 3 times 3 times 5. X squared has how many x's?
2.
2. Okay. We are talking about what kind of root?
I used to think that. 2.
Think what?
That like when you have like the x in the square, I used to think that like it was like 3 x's because you have 1 x already out and
Oh.
2 x up there at the top. But it's telling you that it's 2.
Yeah, it's telling you there's 2 of these. So we're talking about a square root. So I have how many pairs? Where do you see pairs? Sets of 2.
1 pair of 3
3's
and 2 pair, 1 pair of x.
and x's. Okay, so what did I not circle?
The 5.
That stays inside.
Mm-hmm.
And then what goes outside?
3x squared.
No?
Just 3x.
Just 3x, right? There's a teacher across from there. This teacher college algebra. He comes from Westfield. He says, buddies are in prison. One gets out, the other gets shot.
What?
I don't know. I thought that was funny. I don't usually teach that way, but that's how he likes to roll. That's fine.
I'm gonna be one.
So what that does is you don't get confused of taking both those x's out and put x squared, right? So yes, 3x times the square root of 5. Let's complicate this just a little bit more. And now we're dealing with cube roots. So I'm looking for sets of
Three.
three of a kind, right?
Mhm.
X, 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 7, 7, 7. Let's break down 24. Does 2 go into 24?
Yes.
How many times?
12.
12. Does 2 go into 12?
Yes.
6 times. 2 goes into 6?
Yes.
3 times.
3 times, and that is prime. 2 times 2 times 2 times 3. How many x's do I have with x cubed? 3 x's. All right, I'm broken down, and now I'm looking for sets of 3. 3 of a kind. What numbers give me 3 of a kind?
3 of a kind, 2.
2's
And X's.
and the x's. So as I write my radical, what goes inside?
3.
The 3 not used, and what goes outside?
2X.
Very good, 2x. That's what you circled. I don't know how you would do this, like one buddy goes outside, 2 get shot.
What?
I don't know. So again, this number indicates how many of a kind you're looking for.
So when it was 4, y'all.
Here we go, let's do a 4. 128 x to the 8th power.
I'm gonna figure that one out. I got it.
All right, so 2 goes into 28,
64.
You got it.
64. 2 goes into 64,
30 something.
32.
32 times. 2 goes into 32,
16.
16 times.
Mm-hmm.
2 goes into 16,
8.
8. 2 goes into 8,
4.
4. 2 goes into 4, 2 times. Let's make sure 1, 2, 3, 4, 5, 6, 7. Okay.
1.
Multiply all that together should get you 128. Those who are old school gamer fans should know these numbers. 8-bit Nintendo, 16-bit Nintendo, Super Nintendo, Nintendo 64, PlayStation. Anyway. Now x to the 8th power.
Dang, bro.
Yeah, back in the 90s, random access memory, these numbers were a big deal. 1, 2, 3, 4, 5, 6, 7, 8.
So there's one pair of 2's.
Okay, so we're looking for, right,
One-
4 of a kind, right?
2's, yeah.
1 pair of 2's,
Mm-hmm.
or 1 set of 4's,
2 pairs of 8. 2 sets of.
and then 2 4 of a kinds of x's, yes? So,
Multiply them.
kind of tricky, what stays inside?
The 2's, the 3 that's right there. So 2 times 4 is 8. So
Very good, 8. 2 times 2 times 2 is 8. This is the 4th root of 8. And then what goes out?
2x. 2x.
2x.
X.
How many did you circle?
Oh, squared.
Square. Okay, good. So I circled 2,
sets,
so that's
yeah,
2.
2 sets now.
Can be a little confusing between an exponent and a root.
Hey, you see you don't have to put that little 4. You don't have to?
Not with squares, only square root. 4th root, 3rd root, 5th root, anything else you do.
Okay,
So
so
when
we
you
go.
have 2 sets of 2, but 1 set of x.
So if I had 2 sets of
It'll be
2's
4.
and 1 set of x, pretend we're talking about square root, it would be what?
4?
Oh, I wish I could do 4x.
Mm-hmm.
So you multiply. So I have one of these. X times x gives me x squared. I just have one of these. But if I had 2, 2 times 2 is 4. Now there is a trick with exponents. For those that with number sense, you probably can get this pretty quickly. If not, just go ahead and write it all out. But 8 divided by 4 is what?
2.
2. It's going to work like that. Your exponent can be divided by the root. If I were to go back, what is 3 divided by 3?
1.
Only one x came out. What is 2 divided by 2?
1.
Only one x came out. Now where you get into trouble is, what if this was a 5? How many x's would come out? 2.5. So 2 would come out and 1 would stay in. So 2 is not divisible into 5. You get a decimal, right?
Mm-hmm.
But 4 is, and 4 divided by 2 is 2,
Mm-hmm.
which 4, you still have one more to get 5. So that other x, that remainder, stays inside. I mean, you can do this really quickly. This is a trick.
I like your method.
But if you just like to break it down real quick, I would recommend doing that. But it is a quick troll. Just divide this by this, and watch out for any remainders because those could be kind of tricky. Because let's say this was a 3, and this was a 8. How many would come out? Very good, because 3 times 2 is 6, right? And how many are left over? 2. That's where it gets tricky. Because 3 does not divide into 8, but 6 does, twice, which leaves me with 2 left over, so they have to stay in the middle.
That's easy.
Okay, well if you can get that, very good. That'll make your life go by a lot quicker. You just have to worry about the numbers.
That was all of them?
Yeah.
So they had some more, like, more examples. They had like the 5, the quad up there, 5, square root over the thing.
What do you mean?
Like, you see how they have 4, the 4x1 at the top? What was, how do I say this? It was 4 cubed,
4th root.
4th root?
Yeah.
Oh, they got a 5th root?
There's a 5th root, 6th root. I can make this 14 root.
Oh, okay.
Then you would be looking for 14 of a kind.